Okay, so in our context, the harmonic oscillator, the relativistic corrections, our perturbation Hamiltonian right there is that. So what we want to calculate is 1 8m cubed c squared in momentum operator to the fourth power n. We want to calculate that right there. Erase that. I'm not talking about relativity anymore. Oh, only vaguely.
Because it's relative.
Okay, camera person. So that's our equation there. Now, ordinarily, if you like brute force calculated this would be very complicated. Even just for the simplest wave functions, like I tried it before. It's not fun. There's a much faster way to do this. Let's look at our momentum operator, or let's look back at our creation and annihilation operators here from earlier. If you multiply, so let's subtract a star from A. The x's will cancel out, and you'll be left with 2I over MW P. So we can write 2H over MW 2. Okay, that'll cancel out because that's a 4, 2, yeah. Negative I. Yes, I had to make the dots. It was important. Okay, let me make sure I'm doing that right. Yeah. H, 2W. Oh, wait, no. MW. Okay, yeah, that's right. I don't think that part's super important, but it's important enough. Well, we can look at this term in here as, because p squared is a Hermitian operator, we can break it up like this. Meaning it's a inner product of something with itself. Meaning that we only really need to calculate and then take the inner product with itself and see what we get. So that means then we can substitute that in. We want to calculate square that operator, negative MWH bar over 2, A minus A plus squared over N. Well, let's expand this out. MWH over 2, let me make sure I'm going to have the right units in the end. M squared, W squared, H bar squared, M cubed, C squared, H bar is E squared. Yeah, okay, we have the right units. a squared minus a plus a minus a plus a plus squared. Well, that, when it acts on n, as we described earlier, just equals n. It's the number operator. And a plus equals a plus minus a plus a plus a plus a. I have unusual jargon, I know. That's just the commutator between the two is just equal to 1. So that whole term altogether is 2a plus 1 equals negative 2n plus 1 n. All right. Now here's where these things, these relations of how the operators act on, the creation and annihilation operators act on a state come in handy. Because you know that when you act on A on the state n, you're going to get n times n minus 1. And then you got to act on it again. So you'll get n minus 1, n minus 2. Minus 2n plus 1 plus, and then a very similar thing like that. You'll go n plus 1, and then n plus 1, n plus 2, n plus 2. So I'm going to go over here. Our cat that we're interested in is n minus 1, n minus 2, minus 2n plus 1, n plus 1, n plus 2, n plus 2. Oh, and we'll eventually got to consider that factor there of negative MW h bar over 2. It'll just go to m squared w squared h bar squared over 4. And then we can't forget the negative 1/8 m cubed c squared, and then the outer product of the ket f with itself, or inner product, I don't know why I keep saying that. That's what we're going to eventually calculate, and that's going to be our correction to the energy. So, looking back over here, now if you were to calculate it's like a dot product, you will really not even that. You'd have something of the likes of this times, you get a bunch of products. You get a bunch of, this times this, this times this, this times this, and but a lot of the terms are of the form n minus 2, for example, just as an example. Well, those are two different states, and when you take their inner product, because nk equals 0, those are going to be 0. So the only terms in this product that we're going to be concerned with are the ones that are this times itself, basically. So that'll square n minus 2, n minus 2, and the other ones would go to 0 because they're not the same, plus 2n plus 1 squared, n plus n plus 1, n plus 2 squared, n plus 2, n plus 2. Those are with themselves. So those all just become 1, which means n plus 1 squared plus n plus 1, n plus 2. Now we're going to write this out. Uh-oh. Sounds like thunder. That's going to cancel. It's going to go to 5n, and we're going to subtract that n. It's going to go to 4n plus 3. That's 2n squared plus 4n squared. That's 6n squared plus 4n plus 3. So our inner product there is just 6n squared plus 4n plus 3, meaning that our energy correction due to relativistic effects is negative 1/8 m cubed c squared m squared w squared h bar squared over, let's see, times 4, that's 32. We're going to cancel that. That's just going to be mc squared times 6n squared plus 4n plus 3. So, to first order the relativistic correction to the energy we're going to factor in the unperturbed energy, and E is approximately of the relativistic harmonic oscillator to first order is approximately this right here. And let's erase that. And erase that. And there we go.